Ellipse problems that I wanted to review with you so that you can successfully complete your homework. Here is an equation given to you. It's in the standard form for an ellipse, and the directions tell me to find the center, vertices, foci, length of the major axis, and length of the minor axis. Well, we can quickly start with the center. We know that the center is going to be located at -1, +5. Beyond that, everything with an ellipse, I really need to think about which direction this ellipse is stretched out, whether it be horizontally or vertically stretched out, because that will tell me which particular variable or coordinate that I need to change in order to find the foci and the vertices. So I can see the bigger denominator, that's always where you look. The bigger denominator in this case is 16, and it's underneath the y. So I'm going to take the square root of that number to get the a value, which in this case comes out to 4. That means that my two vertices are 4 units away from the center. And I know that this is a vertical ellipse because this bigger denominator is underneath the y. So I will be making changes to the y coordinate. I'll add 4 to the y coordinate to go up 4 units to the vertex. And I'll also subtract 4 to go down 4 units to get to the other vertex. Now I have my two vertices simply by adding and subtracting that a value from the y coordinate of the center. And now I want to go ahead and figure out where the foci are going to be. This takes a special formula. So the c value that we need, we will find with this equation. C is equal to the square root of a squared minus b squared. So for this particular problem, remember 16 already represents the a squared and 4 represents the b squared. Those are underneath the fractions. So I'm going to use those. And I simplify my radical. So now the idea is that the two foci are actually this many units away from the center. 2 radical 3 units up and 2 radical 3 units down. So I'm going to just add and subtract this c value from the y coordinate of the center. That will get me my two foci. Okay, so with this done, I have most of the things I'm looking for. The final two questions, what's the length of the major axis and the length of the minor axis? To complete this question, you just need to realize that the major axis is the axis that actually contains the center, the vertices, and the foci. So I have this little diagram with this vertically stretched out ellipse that we have in this case. The center and the two vertices are labeled. And what I'm going to do is just realize that this major axis actually just runs right through the center and the vertices. So if I want to find the length of this, I just really need to think about what that a value was and double it. We knew from the equation that the a value was 4. So to know the full length of this major axis, we'll just double that, because 4 plus 4, or in other words, 2 times 4, is 8. Now we're also asked for the length of the minor axis, which in this case goes horizontally. So just think about what the b value is. From the equation at the top, we can see that the b value would actually have to be the square root of 4, or 2. And that's the distance away horizontally in each direction from the center to get to the edges of the ellipse. So in this case, the length of the minor axis would be 4. Let me write that out and we'll be done with this problem. There you go. So this problem is complete. we had an equation for an ellipse. So I start off with the center, use the a value to find the vertices. Then I calculated the c value with this formula right here and calculated in the foci. Finally, I just took a peek at what the a value and the b value are and just doubled them respectively in order to find the length of the major axis and the length of the minor axis. Hope that helped. Bye-bye.